Hey guys, today we're going to talk about molecular geometry. We are on page 15 of your notes. So this is to expand on what we learned about when it came to Lewis dot structures. Okay, so the shape of a molecule, determines many of its physical and chemical properties. Okay, so we're going to learn about something called VSEPR theory, or VSEPR theory. And VSEPR stands for valence shell electron pair repulsion theory. Okay? So what that it sounds big and fancy, I know. Basically, all it means is that electrons want to get as far away from each other as possible. Okay, that's basically all it means. They're repulsed by each other. You guys know what repulsion is, right? If I'm repulsed by you, I think you are disgusting and I want to get away from you, right? So that's how electrons are towards each other, because they're all negatively charged. They're repulsed by each other. They're not attracted to each other. So electron pairs orient themselves in order to minimize repulsive forces. So basically, they try to get as far away from each other as possible. Okay? Now, when we're looking at Lewis dot structure, we have different types of electron pairs. We have bonding pairs of electrons, and we have lone pairs of electrons. Okay? So, and based on how many bonds and how many lone pairs you have, that's going to determine your shape. And we're going to learn about 5 different shapes this year in 8th grade chemistry. There are more shapes that exist out there in the world, but these are the 5 most common that we're going to just focus on this year in chemistry. And you will have to have these memorized. I will never require you to draw these little 3-dimensional pictures. This is just for your visualization. What you'll have to have memorized is the name. So like if I give you a Lewis dot structure, you have to be able to tell me what it's called, whether it's a linear shape, a tetrahedral shape. So let me show you what I mean. So first thing you have to do is you have to draw Lewis dot structure. So for the first one, let's do CO2 first. I'm going to split this one in half. So for CO2, first thing you always got to do is add up your valence electrons. You have 4 for carbon, you have 6 for oxygen. That gives you a total of 16 electrons, okay? Now, if you remember, we did this in our notes on page 14, and if you have no idea how I'm doing what I'm doing right now, go back and watch the video for page 14. Okay, cool. So I just kind of skipped ahead and drew the structure right there. Okay, so now, when you have a Lewis dot structure that's complete and correct, you want to look at the central atom. Okay, you want to look at the central atom. So I'm going to put this right here. Around the central atom. Okay, you need to write that down because later on you're going to need that information. Okay, around the central atom. So carbon is our central atom because it's at the center. So around my central atom, what do I have? I have a double bond here and a double bond here. So I'm going to count up how many bonded pairs and lone pairs. Now I want to highlight something really, really important. When we're counting up bonded pairs and lone pairs, a double bond or a triple bond is just going to count as 1. It's just going to count as 1. So here's 1, here's 2. So I have 2 bonded pairs. And I have no lone pairs around my carbon, 0. Whenever you have 2 bonded pairs and 0 lone pairs, it's what we call a linear shape. Okay? Now remember, a bonded pair is whenever you see a bond like this, okay, like a line, or a double bond, or a triple bond. Okay? That's what we're counting here. So I have 2 of those. 1 here, 2 of those. A lone pair looks like this. Now again, we're only looking at the central atom. So yes, there are lone pairs here, but I'm only interested in what's around my central atom. So because there are no lone pairs around my central atom, it's linear. Okay? Okay, now, what if you have something like this that's a diatomic element? So I'm going to make a note over here, and you should too, that diatomic elements, really anything that only has 2 elements in it, is always linear because there is no central atom in a diatomic element. Okay, so for oxygen has 6 electrons. There's 2 of them. So that's 12 total valence electrons in our picture. So it will look like this. You'll end up having to form a double bond. 2, 4, 6, 8, 10, 12. Okay, so here is Lewis dot structure for diatomic oxygen, guys, there's no central atom because there's just two things. There's nothing in the middle. So if that is the case, you don't have to worry about counting up because there's no central atom. You just say, oh, that's linear. Okay? If it's something diatomic, you just say, oh, linear, because it's the only shape it could possibly make is a straight line. Okay? So it's going to be linear. Okay, next one. This totally got chopped off. It's supposed to be BF3. BF3. Okay, so I've got boron, I've got fluorine. Let's add up our valence electrons. Boron has 3, fluorine has 7. I'm going a little bit fast because I assume that you already took notes on those dot structures on page 14 and you've become somewhat proficient at that. Okay, so I'm going a little bit faster so that this video isn't 1,000 years long. And if you forgot how to draw Lewis dot structures, go back and watch the video for page 14. Okay, I'm filling up my octets. I've used all my 24 electrons, and everything has an octet that needs it. Remember, boron's an exception to the octet rule. Boron doesn't need 8 electrons around it. It only needs 6 electrons around it. So I am done. Okay, I am done. Okay, so I'm going to look at my central atom, which is boron, and it has 1, 2, 3 bonds around it, and it has 0 lone pairs around it. There's no lone pairs around my boron. There's lone pairs around my fluorines, but I'm not interested in that. I'm only interested in my central atom. There are 0 lone pairs around boron. So whenever you have 3 bonded pairs and 0 lone pairs, it's called trigonal planar. Okay? Next one. Okay, I've got carbon, and I've got hydrogen. Okay, carbon has 4 valence electrons, hydrogen has 1, but I've got 4 hydrogens, so I gotta quadruple it. So my picture should have a total of 8 valence electrons. So I'm gonna put carbon in the middle with 4 hydrogens around it. I'm gonna connect them with bonds, and I have used all 8 electrons. I'm done, which is fine because carbon has an octet, but hydrogen doesn't need an octet. Remember, hydrogen is another exception to the octet rule. Once hydrogen has formed a bond, it has 2 electrons around it, it's happy as a camper, okay? So I'm going to look at my central atom, which is carbon, and it has 1, 2, 3, 4 bonds around it. Okay? It has no lone pairs around it. Whenever you have 4 bonds and 0 lone pairs, it's what we call tetrahedral. Now remember tetra, we talked about that before. Tetra, tetris, tetra means 4. So that one's easy to remember for me because I remember, tetra means 4. If it has 4 bonds, it's tetrahedral. Okay? Okay, this one, NH3. Got nitrogen, I got hydrogen. Nitrogen has 5 valence electrons, hydrogen has 1 valence electron. However, there are 3 of these. So that's a total of 8 electrons. Never skip this step, guys. Never, ever skip this step. Always do the math first. Okay. Put nitrogen in the middle. I'm going to put 3 hydrogens around it. I've used 6 electrons. I need to use 8, but hydrogen's happy the way it is, but it looks like nitrogen needs an octet. So I'm going to put a lone pair on the nitrogen like that. So I ask myself, does everything have an octet that needs an octet? Let's see, nitrogen needs an octet, and it has 2, 4, 6, 8 things around it. So nitrogen's happy because nitrogen has an octet. Hydrogen does not need an octet. Hydrogen is an exception to the octet rule. If you look at page 14, it says that hydrogen and boron are exceptions. Hydrogen only needs 2 things around it, so hydrogen's happy. Now, let's look at my central atom, which is nitrogen. I see 1, 2, 3 bonds, and I see 1 lone pair. Whenever you have 3 bonds and 1 lone pair around your central atom, it's called trigonal pyramidal. Trigonal pyramidal. It kind of makes a pyramid shape. Okay? And this is what it would look like 3-dimensionally. Okay? And the reason why they orient themselves like this, and the reason why these form different shapes, is because they have different numbers of electrons around them, and all these electrons are trying to get as far away from each other as possible. Okay? So they're all trying to get as far away from each other as possible. So that's why they form these different shapes. So now let's look at this one, because this one's similar to trigonal pyramidal. You have H2O. Hydrogen has 1 valence electron, but there's 2 hydrogens. Oxygen has 6 valence electrons, so it's a total of 8 valence electrons in this picture. Okay, let's put oxygen in the middle, put 2 hydrogens around it, and then we need to fill up oxygen's octet. So I've used 8 valence electrons, oxygen has an octet, hydrogen's good the way it is. Now, however, I'm going to tell you guys that a lot of students draw water this way when they first see it. But I want you to know, I want you to write this in your notes, that this is the way water actually correctly looks. Your lone pairs are going to be like this, and they kind of push it down like this. Okay, this is the correct way to draw water, because this will become more important later, because it shows that water forms this bent shape. So I'm looking at my central atom, which is oxygen. It has 2 bonds around it. It has 2 lone pairs around it. Whenever you have 2 bonds and 2 lone pairs, it's bent, okay? It's what we call a bent shape. Okay, cool. So that's it. So literally it's the same as what we did before. All you have to do is draw the Lewis dot structure. Once you draw the Lewis dot structure, you just have to count up the bonds and lone pairs and then look at this chart to figure out what the shape is. Okay, so on the back, you're going to do this whole thing is a U-try. You're going to do all this on your own. Tally up your valence electrons, draw your Lewis dot structure. Tell me how many bonds and lone pairs are around the central atom. Again, around, write this down, central atom, around the central atom. How many bonds and how many lone pairs around the central atom? And then based on that, you can tell me what the molecular shape is. So if you have, like, for example, if you have 3 bonds and no lone pairs, you would write trigonal planar, okay? If you had 3 bonds and 1 lone pair, you'd write trigonal pyramidal, okay? So use this is your reference to do the back. Now I want to point something out, okay? These guys, people get trigonal planar and trigonal pyramidal mixed up. What's different is that trigonal planar has no lone pairs, trigonal pyramidal has 1 lone pair. Okay, people get those mixed up because they look really similar. And then tetrahedral, remember, it's easy to remember tetrahedral because tetra means 4. Do you remember that from Tetris? Tetra means 4, just like when we were learning about covalent compound naming. Okay, go ahead and complete the back, and then you're going to take a picture of it and submit it.